Hello my people, let's look at the parabolic function, the fastest way to sketch a parabolic function. We are given the graph of y equals to x squared minus 3x minus 4. The first things first, if we want to sketch a parabolic function, you need basically 3 points. So what we need is the x-intercept, and we need the y-intercept, and then we need the turning point. With these 3, you can sketch any parabolic function. With these 3, you can sketch any parabolic function. You also have to understand how to solve trinomials. Factorization involving it makes it easier, or you can also decide to use the quadratic formula, which is a little bit complex, but that works perfectly well for equations or expressions that cannot be easily factorized. So how do we get our x-intercept? The normal thing, make y 0 in the given equation and factorize. Factorization, remember two values that you add to get this, multiply to get this. So our factors here is minus 4 plus 1 will give us negative 3, minus 4 times 1 will give us this. So these are our factors. If we are solving for x, we have x equals to 4 and x equals to negative 1. So as coordinates, our coordinate here is 4 and 0, remember y is 0 and negative 1 and 0. We have our x-intercept. Now we need our y-intercept. For our y-intercept, make x 0. So if we have y equals to x squared minus 3x minus 4, if we make x 0, the only thing left here is negative 4 because 0 squared minus 3 times 0 is gone. As a coordinate, we have 0 and negative 4. Remember, do not make the mistake of swapping your coordinate. X must come before y. And then what else do we need? We need our turning point. We have 2 ways of finding the turning point. Add these 2 and divide by 2. Or better still, go pick up your points on the graph. Let's use that approach. I have x is equals to 4, so I'll pick up 4, and x is equals to negative 1, I'll pick up negative 1. Now start counting. From negative 1 to 0 is 1 point, 4 to 3 is 1 point, 0 to 1 is 1 point, 3 to 2 is 1 point. So we have this. So if you count equal distances where your x or the middle of this is your x value of the turning point. So if we can see here, the x value of the turning point, x is equals to 1.5. Alternatively, if you want to use the formula, we have the formula for getting the x value of the turning point is minus b over 2a. Note that every quadratic function has this general formula, ax squared plus bx plus c. That means, in this case, this is our b. The coefficient of x is our b. So this is 3. So if we have x is equals to negative of negative 3, all over 2 times a, which is 1 in this case, we have 3 over 2, x will still give us 1.5. So either way, if you want to do the counting and balancing, or if you want to use the formula, that will give you the x value of the turning point. To get the y value of the turning point, this x, substitute the x value into the original equation. So we have anywhere we see x, we replace it with 1.5. And then we get the value of this to be 6.25 by calculation. Negative 6.25. So punch your calculator, you get this as negative 6.25. It means that the coordinate of our turning point is 1.5 and negative 6.25. And I'm telling you, with these 3 points, with these 3 coordinates, you can sketch your graph. So we have this, we have our y-intercepts, and we have 2 of our x-intercepts. And with these points, we can easily sketch any parabolic function. Sometimes it gets easier than it will be very easy for you to get your y-intercept in some cases where we have ax squared plus q as the format. Example, 2x squared plus 4 or minus 4. If I have this, then the y-intercept serves as a turning point as well. Then I don't have to go through all these calculations. I'll just get my x and plug it against my y-intercept, and I have my perfect graph. Now let's look at this. I have negative 1 as my first point, and I have 4. So plot your x-intercepts. My y-intercept here is 0 and negative 4. Let's extend this. Going that this will be negative 6. And then it means that my turning point will be 1.5 for x and 6.25 for y. Now I can join all these points using a freehand sketch. Remember, it's supposed to generate a curve. Then this will be my graph. Make sure you don't draw beside the point, it must be exactly on the points. And this will be the graph of g, which is my parabolic function. So remember, for linear functions, you just need x and y intercept to sketch a graph. For parabolic functions, the same approach, x and y intercept, but because it forms a curve, we then need the turning point. Remember, if a is positive, it will give you a smiley face, and if a is negative, it will face down. That's just the difference here. But this is the fastest approach on how to sketch your parabolic functions. Keep studying and good luck for the exams.